Now moving on to motion of a simple pendulum. Now if we take an example of a simple pendulum जिसको हम oscillate कर रहे हैं with a small angle theta. So we can resolve its forces and then apply Newton's second law to basically prove कि जो हमारा pendulum है it is moving in simple harmonic motion. So if we take the right direction as positive, so the component of weight है of the pendulum, it will be given by minus mg sine theta, which you can see it is resolved in the diagram on the right. So this negative sign in the equation shows that basically the force which is acting on the bob is accelerating it towards the equilibrium position. So Newton's second law की equation में we'll replace A with g sine theta and we'll get the equation where A is equals to minus g sine theta. And since हमने ऊपर assume किया है कि जो value of theta it is small, तो हम approximate कर सकते हैं कि sin theta is equals to x over L. जहाँ पे x is basically the bob's displacement from the mean position and L is the length of the string the bob is attached to. और अगर हम इस इक्वेशन को एक्सेलरेशन की इक्वेशन में सब्सटीट्यूट करेंगे we'll get a is equals to minus x multiplied by g over L. So previously हमने कैलकुलेट किया था कि the formula for the acceleration is a is equals to minus w square x where w square is equals to g over L. So if we substitute this in the formula for time period, we'll get t is equal to 2 pi multiplied by underscore L over g. So इस formula से we can note that the time period of the pendulum is independent of the mass of the bob and it is also independent of the amplitude of the oscillation. So we can see कि जो हमारा time period है, it is only dependent on the length of the pendulum.